We'll try it later. Okay, anyway, let's do this. When we have radical equations, what we're talking about are expressions with an equal sign, and they also have a radical. They have a variable inside the square root symbol. And so an example of this would be the square root of x plus 2 equals 5. All right, is that an equation? Yes, because it has an equal sign. And is it a radical equation? Yes, because the variable is inside the square root symbol. Okay? First step on all these problems is to get the radical isolated. What does it mean to be isolated? By itself. And what did I say to get by itself? The radical. I did not say to get the variable by itself. I said the radical. Okay, the radical right now is being added with 2. How do I get rid of that adding of 2? So you'll subtract 2 from both sides, and you'll be left with the square root of x equals 3.
So back to my question. If that was over the whole thing,
I got a question
the whole thing, and then you squared it. If that was over the whole thing, and you squared it, it'd just be x plus 2.
No, it'd be x. If you squared the whole thing, you'd get.
And you cancel out the.
You would get a trinomial if you did squaring everything, which you don't want to do. But here, I don't want the square root of x. I want x. How do you get rid of a square root symbol? Square it. But what you do to one side, got to do to the other. All right. What happens with the square root symbol and the squaring? So you get x equals 9. Now, on all radical equations, you must check your answers because sometimes they don't. All right, let's see. What's the square root of 9? 3 plus 2? So this is the correct answer because it checks.
Wait. Can you say how you checked it again?
Yeah, you just put in 9 for x. 9 for x. You do the square root of 9, which is what? 3 plus 2? 5. So you can check it. You can do it mentally, or you could do it with. Yeah, you can actually work it out. That's it. All right.
Could you do 2 answers for some of these problems, or are you already just making?
These are going to give you 1. If you're square rooting both sides, you get 2. But we're going to square both sides, and that's the difference. Okay, here's your problem. You have an equation, and it's a radical because the x is inside the radical. I told you to isolate the radical, not the variable. So I'm isolating this whole thing. But what's happening to this whole thing? It's being multiplied by, so I have to undo it by dividing both sides by 5. So keeping that equation balanced, that whole idea of balancing an equation. Do you guys remember this from one of the first problems we did this morning? What happens to this 5 and that 5? They cancel out, right? That's what we did this morning. So you get the square root of x minus 2 equals 1. Okay, is the radical isolated? Yes, it's by itself. So now you have to square both sides to get rid of that radical, because you don't want that radical in my problem. And what do I end up with? You still end up with x minus 2 equals 1, because 1 squared is 1. Then what do you do?
Plus 2 on both sides.
Yeah, you add 2 to both sides, and you get x equals 3. Okay, hold on though, because I want to make sure everyone's getting it. Remember, I did all this stuff. So this is the original problem. What's 3 minus 2? What's the square root of 1? 1 times 5? So I got it. This has to be the right answer, right? That's what you're doing. That's the gist of the lesson today, and tomorrow, for that matter. Okay, but then you get ones that are not as simple. All right. What's your first step on these problems, guys? You have to isolate the radical. Isolate that radical, which sometimes is by itself or has things added to it. Okay, look at the radical. What's happening to the radical first? Multiply by 3, and then it's being added with 8. What do you have to undo first?
Oh, wait.
Yeah, you have to you have to undo the thing that happened to it secondly. So you get 3 times the square root of x equals negative 6. All right, and so how do you isolate that radical further? Divide both sides by 3. You get the square root of x equals negative 2. All right, but I want to get x, not the square root of x. So you square both sides, and you get x equals
4.
good, 4, positive 4. All right, let's check this out. Square root of 4? 2 times 3? 6 plus 8? Oh.
So it's wrong.
False. No solution.
You write no solution. Or, for some of you who like shorthand, you could put a null set. That means no solution.
But this, I see false.
Huh? No. You put this or that. So this is your shortcut. Yes, ma'am.
When you were checking it, what did you do with the 3 multiplier?
So, remember the square root of 4 is 2. And what's 2 times 3? Because remember, these are being multiplied.
Okay.
Is 6. 6 plus 8 is not 2. Okay, so that doesn't work, and sometimes that happens. Now, here's how you know it didn't happen. It shouldn't have worked. I'm going to rewrite this part right here. It was the square root of x equals negative 2. Can you ever get a value? Can you ever do a square root and get a negative number? Can you ever get the positive square root and get a negative number? That already told you it was a no solution right there. But if you forgot, you plug it back in, figure it out.
Is it also, Mr. A?
In this case, there's no solution, and then later it's going to be imaginary numbers. Okay, sorry, John. Go ahead.
Couldn't it also be if there's a on the outs? So, okay, negative 3.
I like these hypotheticals.
Negative 3, and then square rooted. Yeah, so that it's basically that.
Oh.
But the 4 is negative, and it equals a positive number. If the 4 is negative, that's not possible, right? Because no matter what you get in the square root, it's going to change it to negative.
Oh, if this were negative,
Yeah.
and that were negative, it could be possible. But if one is negative and the other one's not, yeah. So you can see that there's possibilities or impossibilities.
So there's a lot of rules.
If you see, yeah, and make sure you're seeing the right thing, because some people say, oh, there's a negative, it can't be it. Well, where's the negative and what does it mean? All right, isolate that radical. So the radical is being multiplied by 4. So how do I undo that? Divide both sides by 4. I get square root of 3r plus 24 equals 3. Okay, so the radical is isolated. So how do I undo square rooting? Squaring. Both sides get squared. What am I left with on the left? 3r plus 24 equals 9. And then go ahead and solve it. Don't give me what the answer is. You go ahead and solve it. So I want to find, here's just a normal equation. This is chapter 1 stuff. Find what r is. And so you're doing that, figuring out what r is. Sorry, can somebody tell me what you do? You don't have to work it out, but just tell me what would you do to undo what's happening to r now?
Subtract 24.
From both sides you would subtract 24, and then you would divide by 3, and you should end up with r equals negative 5. Now, okay, hold on. Can you get a square root that's negative?
Yes.
Can you get a square root that's negative?
No.
Never. But that's not saying your square root's negative. That's saying r is negative. Is that possible?
Yes. See?
What's 3 times negative 5?
Negative 15.
Negative 15 plus
9.
square root of 9?
3.
3 times 4?
12. It worked.
Don't hate on negative numbers.
Yeah. I hate
It's
negative
only
numbers.
if you had it over here. If this were negative, you couldn't do it. But check your answers is the whole idea. That works. Any questions on why it works or doesn't work? Yes, ma'am.
For the when you do 3r plus 3 equals 9, so you
Subtract 24 from both sides.
would you divide that?
Divide that number by 3. Both sides by 3. Yep. Just like you did before. Yes, sir?
I just like tried to simplify 3r plus 24, so I made it r plus 8.
Okay.
It didn't work.
Because you divide everything by 3 is what you did, but you would have had to divide everything by 3, But the reason that still wouldn't work is because that was square rooted. Oh, how about this? You could do it here. Divide everything by 3. It would have gotten it. But not with radicals and normal numbers mixed together. Sorry, let me give you your homework and then I'll get the question. 2 through 12 even. As you guys already saw. Yes, I can. I'll test it out.
Okay.
I don't know.
Mr. Ray, why is there a way that you can still get no solution after we solve it?
That means you did everything. Oh, that's right. It got erased. That means you worked through all mathematical processes, but you know what? I'll get them later.
So leave in page 2.
John, the reason why you can work it all out so get no solution is because remember how we put, okay, whatever. You do something, something, something equals something, something. That was technically not true. It was a false equation to start with.
So even though we did it like right.
Yeah, and you know what that means? Sometimes an engineer or a builder, they put up an equation, they work it out, it works. But it was a wrong equation. So they worked out a wrong thing. It worked, but it didn't, it's not right.
Mr. Ray, can we try the white background on white?
Black on white?
White background.
Okay, so black? No, yeah.
Or white on black?
White.
White background. Black.
Everyone have this down? I don't mind trying that.
Because of the problems, how do you know what's new first? Is that like
Isolate them.
You could do the white one or the gray.
Oh, it worked.
Oh, it works.
Hold on, let's check it.
No, black. No, right on the top. Right on the top. The top is
There's no glare, Mr. Ray.
Yeah, there's no glare.
Okay, hold on.
Wait.
There's a little bit, but it's not as bad. You're
So
really
that's,
dark.
yeah, that's what happens. When I come in, it messes it up.
Just get right or
That's a lot better.
Mr. Ray,
It's not like we have to see your
He's still recording.
Mr. Ray, just wear it.
Mr. Ray,
Go with the gray, the light one.
You're still recording.
So, about you recording me? How dare you? All right, goodbye.